Calcium is a very interesting and useful chemical element. Calcium is a very reactive and soft metal. It has the symbol Ca and has the atomic number 20 in the periodic table. It lies in the second group and in the fourth period in the periodic table. The usual state of matter of calcium is solid. It is one of the alkaline earth metals. This is what calcium looks like. Because calcium is number 20 in the periodic table, it means that it has 20 protons and neutrons in the atom nucleus, and it has 20 electrons spread in 4 outer shells. As I mentioned before, calcium is a very reactive metal. As you can see, it has 2 electrons in the outer shell, which means that it would very much like to get rid of them because of the octet rule. If it get rid of those 2 electrons, it would have 8 electrons in the outer shell and would therefore look like one of the noble gases. This is what the calcium ion looks like. It has a positive charge because electrons are negative, has a negative charge, and when it loses them, it will become positive. Free calcium is also occurring in nature. Not exactly free calcium, but ionic compounds with calcium. And it is among other very abundant in water. It actually occurs naturally in water because calcium is a part of the Earth's crust. Calcium is a very reactive metal, and you can also see that in the electrochemical series. It will react to hydrogen and oxygen, and calcium reacts with water. The reaction forms calcium hydroxide that dissolves in water as a soda. What you see on this picture is calcium carbonate, which is a very common ionic compound. The carbonate has reacted with calcium because it needs 2 electrons, and calcium needs to get rid of 2 electrons, and therefore there's balance. Carbonate is a polyatomic ion, which means that they're composed of 2 atoms and covalently bonded between carbon and oxygen, which means that they're acting like a single unit. Calcium is very usual and it is essential for every living survival. We need calcium to function and to survive. Here you can see a picture of what calcium is good for, that it is good for many things in our body. And our parents always wanted us to drink milk because it is filled with calcium. Some people even take calcium pills because they don't get enough calcium. Chalk or limestone is also very commonly found in nature, and picture is from Møns Klint in Denmark, which is a chalk cliff. Calcium is also used for other things. For example, making the yellow color in fireworks and helping creating cement. The experiment I've chosen is a reaction between hydrochloric acid and calcium carbonate. In this experiment, the calcium is going to make calcium chloride with the chloride, and it's going to make water and carbon dioxide. Here you can see the hydrochloric acid reacting with the calcium carbonate, and you can see that the carbon dioxide is bubbling. Here you can see that it has made this clear liquid of calcium chloride and water. Although the calcium chloride is completely dissolved in the water and is dissociated in calcium ions and chloride ions in the water, but you can't see that. This is what the chemical equation looks like, and as I said, the calcium carbonate and the hydrochloric acid has made calcium chloride and carbon dioxide and water. On this picture you can see what the reactants and the products are in this chemical equation. They have made an ionic bond, and they can do that because of the noble gas rule. The calcium needs to get rid of 2 electrons, and 2 chlorines need to have 2 electrons. The ionic bonding is strong because the 2 elements are attracted to each other. The calcium has a positive charge and the chloride has a negative charge. Calcium also has isotopes. An isotope is when there's extra neutrons in the atom nucleus. In this picture you can see the abundance of isotopes of calcium. As you can see, the calcium-40 isotope has the abundance of almost 97%. That means that it's the calcium that we know and the calcium that is the chemical element in the periodic table. And these 5 isotopes are the stable isotopes of calcium. On this picture you can see that the atomic mass of calcium is 40.08 AMU, which means atomic mass units. The atomic mass is not just the mass of one calcium atom, but the atomic mass is the average mass of all the isotopes of an element. And as we saw in the previous picture, calcium has isotopes. You find the atomic mass by taking all the isotopes and multiplying them with the percentage of how common they are, where the percentage is divided by 100. In that way you can see that the calcium-40 isotope is the most common and most abundant and is therefore what the atomic mass is closest to.